Hello, this is Tomotaka Kobayashi, a doctoral student at Waseda University. This is a video for our poster presentation titled Estimation of the Heat Generation of the Metal Composite Powder Absorbing the Pulsed Flow of Hydrogen Gas. Here is the introduction. Almost heat generations in the exposure of nickel or palladium powder to hydrogen or deuterium gas were reported. Especially, we focused on the anomalous heat generations in hydrogen or deuterium gas absorption by metal composite powder reported in previous research. In our previous report, fundamental experiments of anomalous heat generation in hydrogen gas absorption were conducted. In the experiments, about 10 Kelvin of temperature rise was observed in the absorption of 0.5 megapascals hydrogen gas by palladium nickel zirconium composite powder at 244 degrees Celsius. In this research, we added the solenoid valve to our reaction system and conducted the hydrogen gas absorption experiment with pulsed flow generated by the solenoid valve. This experiment aims to increase heat generation by instantary pressure rise and temperature rise due to adiabatic compression. First, the sample is set in the reaction chamber. Next, the chamber is evacuated and preheated. After preheating, the pulse flow of hydrogen gas is loaded into the chamber. During the experiment, sample temperature is measured by a K-type thermocouple. Specification of the reaction system and experimental conditions are shown in these tables. In the experiment without pulse flow, about 12 Kelvin of temperature rise from the control experiment using nitrogen gas was observed in hydrogen gas absorption by palladium nickel zirconium composite powder without pulse flow. On the other hand, about 35 Kelvin of temperature rise was observed in the experiment with pulse flow. This result may show that the pulse flow increases the temperature rise in the hydrogen gas absorption by palladium nickel zirconium composite powder. The calorific value and wattage in the experiments were also estimated under the assumption that full generated heat was absorbed by the palladium nickel zirconium composite powder. 17.2 joule and 0.22 watt of heat generation was estimated from the result of experiment without pulse flow. On the other hand, 48.4 joule and 5.38 watt of heat generation was estimated from the result of the experiment with pulse flow. Here is the conclusion. We added the solenoid valve to our reaction system and conducted the hydrogen gas absorption experiment with pulsed flow generated by the solenoid valve. The experiments of hydrogen gas absorption by 3.0 grams of palladium nickel zirconium composite powder were conducted under the condition that 240 degrees Celsius of initial temperature and 0.9 megapascals of hydrogen gas pressure. As a result, about 12 Kelvin of temperature rise was observed in the experiment without pulse flow, and about 35 Kelvin of temperature rise was observed in the experiment with pulse flow. We also estimated calorific value and wattage in the above experiments under the assumption that full generated heat was absorbed by the palladium nickel zirconium composite powder. As a result, 17.2 joules and 0.22 watts of heat generation was estimated from the result of the experiment without pulse flow, and 48.4 joules and 5.38 watts of heat generation was estimated from the result of the experiment with pulse flow. These results may show that the pulse flow increases the calorific value of heat generation in the hydrogen gas absorption by palladium nickel zirconium composite powder. This work was supported by granting aid for JSPS Fellows and the grant of the Thermal and Electric Energy Technology Foundation. We appreciate Technova Incorporated for the useful discussion and for providing the sample of palladium nickel zirconium powder. Sincere thanks are also due to the other members of the NITO laboratory for their help.